Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Fazullah and you are watching Easy Mathematics. We shall present a quick introduction to matrices. In this video, we shall study these topics which you can see on the screen. Let us start from the first topic. Matrix, a rectangular arrangement of numbers enclosed by square brackets, is called a matrix. Matrices are denoted by capital letters, just like capital A, B, or C, etc. Generally, a matrix can be written as A is equal to a 1, 1, a 1, 2, up to a 1n. Similarly, a 2, 1, a 2, 2, up to a 2n, and up to so on, then a m1, a m2, up to a mn. And now if I enclose it by square brackets, then this arrangement is called a matrix. The horizontal arrangement are called rows of the matrix. For example, this one is first row. Let us say this is row 1. This one is second row, row 2. And this one is up to m row. So we can say this is row m. The vertical arrangement is called its columns. So for example, this one is column 1. We can say this is C1, all elements on this column. This is called column 2, C2, and so on. Now, the elements A1, 1, A1, 2, A1, 1, A2, 2, A3, 3, up to so on. These elements is called principal diagonal. This is called, we can say this is principal diagonal. Now, what we mean by order of a matrix? So if there are R rows and C columns in a matrix, then R cross C is called order of that matrix. Let us say we have a matrix A, just like we can see above. So what will be order of this matrix A? Its order is rows into columns. So we can see there are m rows and there are n columns. So order of this matrix is m cross n. Let us say there is a matrix B, 1, 2, 7, 3. Now we can see the order of this matrix is rows into columns, and we can see there are 2 rows and 2 columns. So order of this matrix B is 2 cross 2. Let us write another matrix D, which is given by 1, 2, 3, 4, 7, 3. Now let us find order of matrix D. So there you can see there are 2 rows and 3 columns. So order of this matrix is 2 cross 3. Row vector. That matrix which has only 1 row is called a row vector. For example, let us write a matrix E. Now, matrix E is 1, 2, 7. We can see there is only 1 row in this matrix. That is why this matrix is called row vector. Row column, a matrix with only one column is called a column vector. For example, let us write a matrix F. And in this matrix, we have A, B, C. So there is only one column in this matrix. That is why this is called a row column. Equal matrices. Two matrices are said to be equal if they satisfy two properties. The first property is they have the same order. The second one, their corresponding entries are same. Let us write an example in which we have a matrix A. In matrix A, there are 1, 2, 2, 1. Let us write another matrix B. In matrix B, we have 1, 2, 1, 2, 1, 0. Let us write another matrix C in which we have 1, 2, 2, 1. Now you can see A is not equal to B because they don't have the same order. But you can see A is equal to C because they have the same order and their corresponding entries are same. First entry of A and first entry of C, they are same, 1, 1. Similarly, second entry of A, second entry of C, they are equal, 2, 2, and so on. Zero matrix, a matrix whose all elements are 0 is called a zero matrix. For example, we denote a zero matrix by O. So if I write a matrix with 2 rows and 2 columns, 0, 0, 0, 0. This is a 2 cross 2 matrix and all entries are 0. So this is called a zero matrix. Square matrix. A matrix having the same number of rows and columns is called a square matrix. Otherwise, it is called a rectangular matrix. For example, let us write a matrix A. And in this matrix, I have 1, 2, 3, 4. There are 2 rows and 2 columns. So number of rows and number of columns are same. That is why this is a square matrix. But if I write another matrix B, in which I have 1, 2, 7, 7, 8, 9, there are 2 rows and 3 columns. So number of rows and columns are not equal. So that is why this is not a square matrix. This is a rectangular matrix. Diagonal matrix. A matrix whose all entries are zeros except on the principal diagonal is called a diagonal matrix. Let us see an example. In this example, we write a matrix A which is equal to 2, 0, 0, 3. And we can see that this one is the principal diagonal. So all entries of this matrix are zeros except the entries on the principal diagonal. So that is why A is a diagonal matrix. Let us write another matrix B. This matrix is 3, 0, 0, 0, 4, 0, 0, 0, 3. Now again we can see that all entries of this matrix are zeros except the entries on the principal diagonal. So this is called a diagonal matrix. Identity matrix. That diagonal matrix whose all entries on the principal diagonal are 1 is called an identity matrix. Identity matrix is denoted by I. I2 mean 2 cross 2 matrix. So let us see an example of the identity matrix, which is 1, 0, 0, 1. So we can see entries on the principal diagonal are 1. So this is an identity matrix. Let us write another matrix I3, which is equal to 1 0 0 0 1 0 0 0 1. Again, entries on the principal diagonal are 1 and the remaining are zeros. So this is an identity matrix. Upper triangular matrix, a matrix whose all entries below the principal diagonal are zeros, is called an upper triangular matrix. So let us see an example. Let us A is a matrix. In this matrix we have 1 2 3 0 1 4 0 0 2. And now we can see that all entries below the principal diagonal are zeros in this matrix. So this is called an upper triangular matrix. Lower triangular matrix, a matrix whose all entries above the principal diagonal are zeros, is called a lower triangular matrix. So let us see an example B. We have a matrix B, and in this matrix we have 3 0 0. Then we have 1 2 0. Now we have 4 3 1. Now we can see that all entries above the principal diagonal are zeros. So this is called a lower triangular matrix. Transpose of a matrix. So if we interchange rows into columns or columns into rows, we get transpose of a matrix. Transpose of a matrix A is denoted by AT. So let us see an example. In this example, we have a matrix. The matrix is 3 2 1 7. How to obtain its transpose? To obtain its transpose, let us write its first row in first column, 3 2. Its second row in second column, 1 7. So this is transpose of matrix A. Let us write another matrix. In this matrix I have 1 2 4 3 2 1 7 4 2. Now what is transpose of matrix B? Let us write it first row in first column, 1 2 4. Second row in second column, 3 2 1. Third row in third column, 7 4 2. This is called transpose of matrix B. Conjugate of a matrix. Taking conjugate of each number of a matrix is called conjugate of a matrix. If we have a matrix A, then its conjugate is denoted by a bar. Now we know that conjugate only changes the sign of an imaginary part of a complex number. So let us see an example. We have a matrix A which is equal to 2 3 iota 1 2 plus 4 iota. Now let us see how to obtain its conjugate. So A conjugate is a matrix by taking conjugate of each number of this matrix. Conjugate of a real number is again a real number. Now 3 iota is an imaginary number, so it will change sign. So its conjugate is minus 3 iota. Again, 1 conjugate of 2 plus 3 plus 4 iota is 2 minus 4 iota. So this is called A conjugate of matrix A, which changes only the sign of an imaginary part. Symmetric matrix. A matrix A is called symmetric if A transpose is equal to A. So if we take transpose of a matrix and as a result we get the same matrix, then A is called a symmetric matrix. Let us see an example. I have a matrix A which is equal to 3, 4, 4, 3. Now let us take its transpose. So A transpose is equal to, let us write first row in first column and second row in second column. And you can see this is again equal to A. So A transpose is equal to A mean A is a symmetric matrix. Skew symmetric matrix. A matrix A is called skew symmetric if A transpose is equal to minus A. Let us see an example. Let we have a matrix B which is equal to 0, minus 1, 1, 0. Let us take its transpose. So B transpose is equal to, write first row in first column, second row in second column. Now let us take minus as common from this. We will get 0, minus 1, 1 and 0. And we can see that this is the matrix B. So B transpose is equal to minus B. This implies that B is a skew symmetric matrix. Hermitian matrix. A matrix A is called Hermitian if we take conjugate of A and then we take its transpose and we get the same matrix A. In that case, A is called Hermitian. Let us see an example. In this example, we have a matrix A which is equal to 1, 2 minus iota, 2 plus iota, 0. Let us take its conjugate. Its conjugate is 1, 2 plus iota, 2 minus iota, 0. And now let us take its transpose. So A conjugate whole transpose is equal to 1, 2 plus iota, 2 minus iota and 0. And now we can see that this is the same matrix A. So A conjugate whole transpose is equal to A. It means that A is a Hermitian matrix. Skew Hermitian matrix. A matrix A is called skew Hermitian if A conjugate whole transpose is equal to minus A. Let us see an example. In this example, we have a matrix B, which is given by iota, 1 minus iota, minus 1 minus iota, 3 iota. Let us take its conjugate, which will change the sign of imaginary part. So we can get minus iota, 1 plus iota, minus 1 plus iota, minus 3 iota. Now let us take its transpose. So B conjugate whole transpose is equal to, let us write first row in first column, minus iota, 1 plus iota. Second row in second column, minus 1 plus iota, minus 3 iota. Let us take minus common from this. We get iota, 1 minus iota, minus 1 minus iota, 3 iota. And you can see that this is the same matrix B. So we can see that B conjugate whole transpose is equal to minus B. It means that B is a skew Hermitian matrix. Addition and subtraction of matrices. So the first rule for addition and subtraction is two matrices are capable for addition and subtraction if they have the same order. It means that if we have a matrix A and another matrix B, and if they have the same order, then we can add and subtract. If they have different order, we cannot subtract or we cannot add these two matrices. How to add two matrices? Let us see an example. In this example, I have a matrix A, B, C, D. Now I have another matrix B, which is L, M, N, P. Now to add A and B, we must add the corresponding elements. The first element with the first, the second with the second, the third with third, the fourth with fourth. So we should add the corresponding elements of matrices. Similarly, to subtract B from A, we must subtract the corresponding elements of B from the corresponding elements of A. Just like A minus L, now B minus M, C minus N, D minus L. Scalar multiplication. Multiplying a matrix by a scalar number is called a scalar multiplication of a matrix. And it is obtained by multiplying each element of the matrix by K. So let us see an example. In this example, we have a matrix A, which is equal to A, B, C, D. And now let us obtain 5A. In this case, K is 5. So to obtain 5A, we should multiply each element of A by 5. So we can multiply A with 5. We can multiply B with 5. We can multiply C with 5. And similarly, we can multiply D with 5. And this is 5A, which is scalar multiplication of a matrix A with a scalar number 5. Multiplication of matrices. First of all, we have to keep in mind that we can multiply two matrices A and B to obtain AB. If number of columns in A is equal to number of rows in B, and if number of columns in the first matrix is not equal to number of rows in the second matrix, then we cannot multiply AB. So let us see an example. In this example, let us take a matrix A. Again, I take A, B, C, D. And let us take another matrix. Let us say this is matrix B. Now, in this matrix, I have E, F, G, H, L, M. Can we obtain the multiplication AB? So look, let us see the number of columns in A, and we can see there are 2 columns in A. And now let us see number of rows in B. So there are 2 rows in B. So as the number of columns in A is equal to the number of rows in B, so we can obtain AB. And now to obtain AB, what we have to do? We must multiply first row with first column of B. So we can obtain A into E, this will be AE, plus B with H, BH. Now we can multiply first row with second column. So this is AF plus BL. Similarly, we can multiply first row of A with third column of B, and we can obtain the third element. So this is AG plus BM. Now let us multiply second row of A with first column of B. So we can obtain CE plus DH. Now we have to multiply second row of A with second column of B. So we can obtain CF plus DL. And in a similar way, we can obtain CG plus DM. And this is the required solution. Now, let us see another example. In this example, I have a matrix. Let us say I have a matrix A. In this matrix, we have 1, 2, 3, 1. And I have another matrix B in which I have 2, 1, 1, 2. And we can see that we can obtain AB. Let us obtain the multiplication AB. So to obtain the multiplication AB, we must multiply first row of A with first column of B. So we can obtain 2 into 1 into 2 is 2 plus 2 into 1 is 2. Similarly, 1 into 1 is 1 plus 2 into 2 is 4. Now let us multiply second row of A with first column of B. So we can obtain 3 2s are 6 plus 1 1s are 1. And now we have to multiply with the second column of B. So we can obtain 3 plus 2. And if we simplify this, we can get 4, 5, 7, and 5. And this is the required solution. Periodic matrix. A square matrix A is called periodic matrix if it satisfies A power k plus 1 is equal to a, where k is a positive integer. Now, if this k is the least positive integer satisfying a power k plus 1 is equal to a, then k is called period of a. If k is equal to 1, in that case, we can write a square is equal to a, and in that case, a is called idempotent matrix. Let us see an example. The example is, we have a matrix A which is equal to 1 0 1 0. Now, if I obtain a square is equal to a into a. So let us write a, which is 1 0 1 0, multiply with a 1 0 1 0. Now, when we multiply this, as a result, we get 1 0 1 0, which is again matrix A. So we can see that a square is equal to a, and that is why A is called idempotent matrix. Idempotent matrix. Nilpotent matrix. A matrix A is called nilpotent if A power P is equal to 0 matrix, where P is a positive integer. Now, if this P is the least positive integer such that A power P is equal to 0, then this P is called order of nilpotency. Let us see an example. In this example, we have a matrix A which is equal to 2 minus 1 4 minus 2. Now let us obtain A square. A square is equal to A into A. So let us multiply 2 minus 1, 4 minus 2 with another A matrix, which is 2 minus 1, 4 minus 2. If we multiply these two matrices, as a result, we get 0, 0, 0, 0, which is a 0 matrix. So we can get that A square is equal to a 0 matrix. And this implies that A is a nilpotent matrix. Nilpotent matrix with nilpotency index 2. Involutary matrix. A square matrix A is called involutary matrix if it satisfies this equation. A square is equal to I, where I is multiplicative identity matrix. Let us see an example. In this example, we have a matrix A which is equal to 1 minus 1 0, 0 minus 1 0, 0 0 1. Now, if we obtain A square which is equal to A into A, in that case we can write 1 minus 1 0, 0, minus 1, 0, 0, 0, 1. And again, we can write matrix A, which is 1, minus 1, 0, 0, minus 1, 0, 0, 0, 1. If we multiply these two matrices, as a result, we can get this matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, which is an identity matrix. So you can see that A square is equal to I. This implies that A is an involuntary matrix.